Dear students, welcome you all back again to another edition of my virtual classroom. Today I am going to take a class in second part of Polygon taken from the mathematics syllabus of class 8. In my previous class I have discussed about the definition of a polygon, types of different polygons, definition of diagonal, formula of getting the number of diagonals present in a polygon, formula of getting the sum of all interior angles of a polygon. So if I ask you before starting today's class, can any one of you answer what is the diagonal of a polygon? A diagonal is a line segment that joins any two non-adjacent vertices of a polygon. So if I discuss it again here, let me construct the figure of a quadrilateral. How many vertices are there? There are 4 vertices. So these 2 vertices are non-corresponding or non-consecutive. Then the line segment joining these 2 non-consecutive vertices is called a diagonal. Similarly, I can construct another diagonal this way. Already you have got the formula of getting the number of diagonals present in a polygon. You could easily remember the formula is what? N into n minus 3 by 2. Is it? N denotes the number of sides of a polygon. So, in case of quadrilateral, if you want to get the number of diagonals without constructing the figure, the value of n is going to be 4. 4 into 4 minus 3 by 2. 4 into 1 by 2. That is 2. Okay. Similarly, we can get the number of diagonals present in any polygon consisting of any number of sides. Okay. Let me rub the board first. In its second part, I am going to discuss about a special kind of polygon in which all the sides are of equal length and all angles are of equal measure. So let me start from the smallest polygon that we have, which is a triangle. So if I construct the figure of a triangle in which all the sides are of equal length and all angles are of equal measure, that is said to be a regular triangle. Got it? I think from your previous knowledge you can easily recognize that it's an equilateral triangle. It's an equilateral triangle. An equilateral triangle is a triangle in which all the line segments, all the sides are equal and each angle is of 60, 60, 60. Is it? So sum total of all the angles is 180. Now if I construct another figure which is a quadrilateral in which all the line segments, all the sides are equal and all angles are of equal measure, then that will be named as regular quadrilateral. Again, could you recognize what this polygon is? It's a square. It's a square in which all the sides are equal and all angles are also equal. And let me tell you, each angle is of 90 degrees because 90 into 4 is 360. That is what I discussed in my previous class, that the sum of all interior angles of a quadrilateral is 360 degrees. Now, a regular triangle is an equilateral triangle, a regular quadrilateral is a square. But if I construct a regular pentagon, then it will have all sides of equal length and each angle will be of equal measure. Okay, so then let me construct the figure of a regular pentagon. A regular pentagon. Suppose this is a regular pentagon. How many sides are there? 5, and all sides are of equal length. And can any one of you tell me what is the measure of each angle present in a regular pentagon? Let me tell you. What is the formula of getting the sum of all interior angles of a polygon? The formula is n minus 2 into 180. Now n is 5 here, so 5 minus 2 into 180, that is equal to 3 into 180, 540 degree. 540 degree is the sum of all interior angles of any pentagon. But since it is regular, so regular pentagon, so it has all angles equal. So let me make each angle is of x degree. Since all angles are equal, so how many angles are there? 5. So I can easily write 5x is equal to 540 and x becomes 540 by 5, that is 108 degree. So if you are asked in exam to write the value of each interior angle of a regular pentagon, that is going to be 108 degree. How can we find the value of each angle of a regular pentagon? That is the process shown in front of you. Similarly, you can find the measure of each angle of a regular hexagon, regular heptagon, regular octagon, and so on. So, I am giving you a task to find out the measure of each interior angle of a regular decagon. Could you be able to do? Okay, let me show you here. So, what is the sum of all interior angles of a decagon? Already we have calculated in my previous class, that is 1440 degree. Is it? So, how many angles are there in a decagon? There are 10 angles. Since the decagon is a regular decagon, otherwise it is not possible to find the measure of each angle. So, that is going to be 10 into x is equal to 1440. Similarly, how we have done in previous case, x is equal to 1440 by 10. So that is 140. Got this? So this way we can find the measure of each angle present in any regular polygon. Now we are moving towards our next point, which is to find the sum of all exterior angles of a polygon. Sum of all exterior angles of a polygon. Sum of all exterior angles of any polygon is fixed. Sum of all exterior angles of any polygon is a fixed one, that is 360. Okay? It is true in case of a triangle, quadrilateral, pentagon, hexagon, even decagon, and so on. Sum of all the exterior angles. So, suppose if I construct a triangle like this, if one side is extended, it's an exterior angle. Similarly, if another side is extended, exterior angle. And what is the sum of all these three exterior angles? Is 360. And I am telling you, it will be 360 degree in case of any polygon. Sum of all exterior angles of any polygon is 360 degree. Now, if it's a regular polygon, then sum of all exterior angles of a regular polygon is also 360, because regular polygon is a special kind of polygon. But there is another special case in a regular polygon. A regular polygon has all exterior angles equal. Okay, so what is the measure of each exterior angles of a regular polygon? So in case of a triangle, how many exterior angles are there of equal measure? We have 3 exterior angles of equal measure. Let each exterior angle be x degree. So x into 3 is equal to 360. So x is equal to 1 degree. So we can say that each exterior angle of a regular triangle, that means equilateral triangle, is 120 degree. Got it? Let me construct the figure again. Suppose it's an equilateral triangle. So if I construct all 3 exterior angles of equal measure, each one is going to be 120 degree. Got this? Similarly, can you find the measure of each exterior angles of a regular quadrilateral? It will be x into 4 is equal to 360, because there are 4 exterior angles of equal measure. So x becomes 360 by 4 is 90. Means if I construct a square which is the regular quadrilateral, so if I extend or produce 4 sides, then I will find 4 exterior angles, and each exterior angle will be of 90 degree. Got this? Similarly, we can find the measure of each exterior angle of a regular polygon using this formula. Got this answer? Now, in the next part of it, we can easily find the number of sides of a polygon if you have the measure of each exterior angle given. Suppose the measure of each exterior angle, let it be each exterior angle of a regular polygon is given as, let it be 36 degree. The measure of each exterior angle is given. Then the question is there, you find the number of sides of the polygon. So according to the question, each exterior angle is 36 degree, then the number of sides is going to be number of sides is equal to 360 by each exterior angle. So 360 by 36, that becomes 10. Got this? So this is a formula. Number of sides is equal to 360 by each exterior angle in case of a regular polygon. You just anyhow remember this formula to find the number of sides of each regular polygon if you are having the measure of each exterior angle. Got this? Now find the number of sides of a regular polygon if each exterior angle is given as 18 degree. It's your task to find out the number of sides. It's only possible if the polygon is regular, otherwise not, because in a regular polygon only all sides and all angles are of equal measures. In its concluding part, I am going to tell you a simple relation between each interior and each exterior angle of a polygon. Suppose a quadrilateral is drawn. The sum of each interior and its corresponding exterior is always 180. Got this? You just remember this particular formula. The sum of each interior and its corresponding exterior is always 180 degree in case of any polygon. And sometimes a question comes in the exam like that. If each, let me write the question here. If each interior angle of a regular polygon is, let it be 60 degree, then find the number of sides of that polygon. Okay, if you are given this question, how to answer that? Each interior angle of a regular polygon is given, but we know the formula of finding number of sides is equal to 360 degree by each exterior angle. Okay, that is the formula we know, 360 by each exterior angle. But we are having the measure of each interior angle. Now recall that formula what you have learned just a bit earlier. Each interior angle plus each exterior angle is equal to 180. Okay? Just a few minutes earlier I have discussed each interior angle, each exterior angle, the sum is 180. What is the measure of each interior angle? Is 60 plus each interior angle is 180. Then what is the measure of each exterior angle? If 60 is taken to the right hand side, it will be 180. So I have got the measure of each exterior angle. Now I can easily find 360 by 120, that is 3. So it's a triangle, and since it is regular, so it's a regular triangle or equilateral triangle. Okay.